Let me paint a picture. It's 10:04 p.m. on a school night. You have an exam tomorrow, and yet here you are. Struggling to build a 3x3 redstone door that refuses to open. You've rewired it 5 times, watched 3 tutorials, and are having hallucinations of mumbo jumbo. Still, nothing.
Why isn't this working?
But what does that even mean in Minecraft? Or even in the real world? To understand that, we need to understand electricity is like water in a pipe. Voltage is the pressure, how badly it wants to move. Current is the flow, how much actually does move. Makes sense, right? Now, let's make it weird. Think of this fence as a wire. The sheep, electrons. Now I'm holding wheat. That's voltage. It's the potential to make them move. But until there's a path, they'll just stare at me. Open a gate and they rush forward. That's current, the flow of charge. Voltage is the push, the potential difference between 2 points. Current happens when that push causes movement. Now notice, some sheep are too far away to care. They see the wheat, but it's too distant. That's like having a tiny voltage, not enough of a potential difference to overcome resistance. Place a torch. Boom, power. Signal that says yes. That's a 1. No signal, that's a 0. That's binary, the entire language of computers. But how do they make decisions? Simple, they think with logic gates. The foundation of everything. Let's start with the NOT gate. The NOT gate takes a single input and just flips it. That's it, it disagrees with everything. In Minecraft, this is built with just a redstone torch. Without flipping bits, modern computing is impossible. The AND gate is picky. It only gives you an output if everything is perfect. In Minecraft, you need both livers on to light the lamp. This gate is used anywhere you need multiple conditions to be true. Launch codes, safety systems, and logic that demands precision. This might sound familiar, as it is a popular movie trope. The OR gate is way more relaxed. Give it 2 inputs, and if either one is a 1, it will turn on. 0 and 0 is the only time it's off. It's like having 2 switches in parallel. Just one needs to be on for the lamp to light. In Minecraft, you simply wire 2 levers to the same dust. This is perfect for alarm systems, automatic doors, and anything where 1 yes is good enough. The NAND gate is a bit of a trickster. It's like an AND gate, but with a twist. It gives you the opposite of what AND would. It's the same as taking an AND gate and sticking a NOT gate on the end. So both inputs are on, and it'll shut down. Anything less, and it'll turn on. It sounds chaotic, but a NAND gate is the workhouse of computing, as you can build any logic system with just these gates. The NOR gate is the opposite of OR. It only turns on when everything is quiet. If even one input is active, it'll shut off. Only when both are 0 does it light up. This one's used in fault detection and reset logic, places where any activity is a problem. Like NAND, it's functionally complete. You could build a full computer with just NOR gates. And then there's the buffer. It doesn't change the signal at all. So why does it exist? Because sometimes a signal is too weak to make it through the next part of a circuit. A buffer steps in and repeats the same thing, but stronger. We'll come back to that. These 6 logic gates are how computers make decisions, one tiny rule at a time. They might look basic, but combine them, and you can build that.
Whoa. If those are all the logic gates, then what are those over there?
Shh. We'll get to those in the next video. They're a little more complicated. See this? That ripple of light across the repeaters? It's not just for cool effects, that's timing. And in electronics, timing is everything. In Minecraft, a repeater strengthens redstone signal and adds delay. In real life, that's a buffer circuit, delay circuit, or RC time constant. In real circuits, we use capacitors and resistors to control how long it takes voltage to rise or fall. It's like pouring molasses through a straw to slow things down. We are just slowing down electricity. Your PC, your phone, pretty much all electronics run on clock signals. Regular ticks that keep everything in sync. In Minecraft, clocks can be made with repeating loops of redstone. In real life, we build them with circuits that pulse on a schedule, like the 555 timer chip. It controls the frequency, duty cycle, and pulse width, basically how fast, how long, and how often something happens. Redstone dies after 15 blocks. Why? Because Mojang said so. In real circuits, signals degrade over distance too. It's called voltage drop, or signal attenuation if you want to sound smart in front of an engineer. This is why we use buffers, repeaters, and amplifiers in real circuits, to keep the signal strong and the data accurate. It's the difference between whispering to your friend next to you and trying to yell across a stadium. So next time your Redstone build breaks, remember, it's not magic, it's logic. Real, actual logic. Minecraft is secretly teaching you how computers work. So go ahead, build a half adder, make a trap, design a mini processor. You're not just playing a game, you're becoming an engineer.
Just like that, it works. No screaming, no keyboard slamming, no blood sacrifices. Just logic.
Sure, you failed your test, but now you're sufficient in Boolean algebra. Came here to build a door. What you really built was a better version of yourself. Also the door though.